questions, you can still ask me. So now let's look at the next questions. I would like to make use of these questions to go through with you. So you take note of this question first. I think take out a piece of papers or whatever medium that you use, your notepad or things that you can write down this. So this is the next question that I want to make use of. Another situations of frame with inclined members, and now the loading also is not acting vertically, it is not acting horizontally, but it is acting perpendicular to the members, So this is the next problem that I want you to, that we will go through together. I'm showing you now the screen, okay? If you cannot see, please let me know. Yeah, now there's a questions in the chat there, why we don't find the forces for x directions. Now, because there is no force, because when we want to take, first of all, if you look at the questions, there is no force, there is no component of this loading which is acting in x directions, So when we take equilibrium of forces in x directions, so we find that the only forces which is acting in x direction is dx here. And if you search around here, there is this loading here all acting vertically. So we find dx is equal to 0. So to the question why we don't find in x directions is because we do not need, there is no forces, or there is, from this loading here, there is no component of the loading which has x direction component. It is all acting in y directions. So for the inclined part, it is only because the question given to us, the loading is acting vertically. The loading is acting vertically, so we don't need to find the forces for x direction for the inclined part. The next example that I'm going to show you is we need to do that. So, Nur Atika, did I answer your questions? Okay, welcome. So that particular point that you point out, Nur Atika, that will be considered in the next question that I'm going to show you. Okay. So the next question is this. So I hope you can see the screen now. So we have this. One moment, please. Okay. So you have this inclined member. And this is vertical, okay? And this is our x and y. Okay? So you have an inclined member, and now it is directly given to us the degree. The inclination is 30 degrees. The inclination is 30 degrees. So this is 6 meter height, and the inclined length is 3 meter. And we have UDL acting horizontally on this part AB, along the whole length, 6 meter, and we have an UDL. This is also UDL, 1 kilonewton per meter, but the direction of action is 90 degrees perpendicular. So this is 90 degrees, acting 90 degrees to the members. So we will see how to consider this. Now, if you check this and just refresh yourself, so statical determinacy 1, 2, 3. So we get this is statically determinate. This is actually statically determinate. Okay. So now to solve this problem, so this is a free body diagram. This is a free body diagram. So AY, AX, MA. So remember, this is one of the important things that you need to take note, how many reaction and support there, depending on the type of support. So now we start with summation of forces in X directions in order to find AX. So look at this free body diagram, we have AX here. Then the next, look at this loading, it is acting horizontally in X direction, so we need to consider them. So how to consider? Get the equivalent load, which is 1 multiplied with 6. This is, I indicate here, this is for this UDL, which is acting in X directions to the right. So next, this is the questions that were asked by Africa just now. So why we don't consider X? So here we need to consider X now, because this loading, which is acting perpendicular, has component in X directions. It has component in X directions. So I show you here, this is the member BC, and this is the equivalent, the load equivalent to the UDL, which is 1 multiplied with the inclined length here, which is 3. So we get 3 kilonewton here. And it is acting perpendicular 90 degrees to this member. And because it is acting perpendicular 90 degrees to this member, this is 30 degree, measure horizontally. So this angle here also become now 30 degrees. Okay. So this is from the trigonometry that we consider if this is 30 degree, which is coming from this question given to us. So this one also becomes 30 degree. So these are the part that you need to know how to relate to by using the information of the inclination of the member. So this angle here, once we know this is 30 degree, now we are looking at forces in X directions. So we need to find the component of this 3 kilonewton in X directions, which is 3 sine 30. So 3 sine 30, then we get the component of this inclined load in X directions. So that is for force. So we solve this, we get AX actually is negative. So meaning that the magnitude 7.5, the direction of action is actually to the left. So the same thing, we look at summation of forces in Y directions. So we get AY going up as positive. Then this is acting in X direction, so it's not going to affect equilibrium of forces in Y directions because it is acting in X direction. So no, it's not going to appear in this equilibrium equation, which is we are looking at force in Y. This one is acting not in X, not in Y, but at 90 degrees to this inclined member. So we need to consider the component of this distributed load in Y directions. So again, I show you the diagram here. The load equivalent to UDL acting on this inclined member is 3, which is 1 multiplied with the length, which is 3 meters given to us. Then you have this 30 degrees here. So the vertical component or the Y component become 3 cos 30. 3 cos 30 going down. So it is negative sign. So we solve this, that we get AY 2.598 and we get positive value, so the direction that we assume going up is positive, is correct. So in this case, we need to consider the horizontal and vertical component of this UDL, which is acting on this inclined member, because this is not acting in X direction or Y direction, but in this direction, which is perpendicular to the member. So this process we have to go through. So next, the third one, to find the moment. To find the moment, so again, I show you the free body diagram here. The free body diagram here. Then we use the third equilibrium equation, take moment at point A equal to 0, consider counterclockwise as positive, so I follow this MA, consider counterclockwise as positive, so MA, when you take moment at A, don't forget this MA, so MA, so minus, so when you take moment at A, you don't have to consider AY and AX now, but you have to consider moment caused by this and moment caused by this. So moment caused by this is given by, find the load equivalent to this, which is 1 multiplied with 6. Then it is UDL, so is acting at the middle of this height here, so which is 6/2. And this is causing clockwise moment, so it becomes negative. So next is this one. This one. So this one, I need you to pay attention closely to this one. So here we want to find moment caused by this. So moment is back to basic. Moment is force multiplied with perpendicular distance. Here, because this is acting inclined at 90 degrees to this inclined member, so we get the component in X direction, and then find the moment due to that X component at point A, and also find the moment due to that Y component at point A. And if we add them up together, it is equivalent to the moment caused by this inclined UDL. So we find the moment caused by the component and we add them up together. So this is what is shown here. So again, I show this diagram. This 3 is the load equivalent to this UDL. And then I get the horizontal component, which is sine 30. So this one, I get the horizontal component. This is a horizontal component of this UDL, which is acting 90 degrees to the member. And this is force only. We need to multiply with the perpendicular distance. Need to multiply with the perpendicular distance. So perpendicular distance is, if I use back this diagram here, so the horizontal component, we want to take moment at A, so the perpendicular distance will be this distance. Okay, and this distance is 6 multiplied with half of this vertical height here, half of this vertical height. Because this is acting horizontally, so this is half of this vertical height. What is this vertical height here? If this is 3, this is 30, so this vertical height becomes 3 sine 30, and half of this divided by 2. So this is where it comes from. Okay, then plus 6, that gives you the perpendicular distance that you need to multiply with this horizontal component to get the moment at A. Similarly, for the vertical component, this is the load equivalent to this inclined UDL cos 30, so you get the vertical component. You get the vertical component cos 30 first. Then the perpendicular distance, so I make use of this diagram here. So the perpendicular distance to where? To the point that you want to take moment. This is the perpendicular distance. And this perpendicular distance is half of this horizontal distance. This horizontal distance will be 3 cos 30 divided by 2. So this is where it comes from. So this is equal to this one here. So again, it is causing clockwise moment, so it becomes negative. So this is how we consider moment caused by this inclined UDL at point A. At point A. And then if you solve this, you get MA 31.5 kilonewton meter positive, which means the direction that you assume, which is counterclockwise, is correct. Is correct. So this is the way we consider loading which is acting on inclined member. The first one we look at, the first example we look at where the load, the member is inclined, but the loading is in vertical directions. But the second example, we look at the case where the member is inclined, the loading also, it is not acting vertically, not acting horizontally or in X and Y directions, but at certain direction, which is, in this case, it is acting perpendicular to the member. So it is acting perpendicular to the member. It is not acting vertically, it is not acting horizontally. Yeah. It's not like this, it's not like this, but it is acting at 90 degrees to the inclined members. So when this kind of thing happen, then we need to go through this process, get the component in X direction, get the component in Y directions, when you want to consider equilibrium of forces. And when you want to consider equilibrium of moment, you have to get the moment caused by the horizontal component and moment caused by the vertical component. Case, and I show you on this page here, it is important to know which perpendicular distance that you need to use. So moment, back to basic, moment is force multiplied with perpendicular distance. So for that reason, if you know how to find this perpendicular distance, I show you here the other way to get moment. This is acting to 3 kilonewton, is acting 90 degrees to this inclined member, which is 30 degrees. One way to find moment is go through this by using the moment caused by the component. But if you go back to the basic, if you want to take moment at point A, you can also find the perpendicular distance in this way. You draw one line here, passing through this force, and then you draw another line parallel to this, and then passing through point A. So this two lines is parallel, and perpendicular distance is given by this distance. So if you can find this distance, then you multiply with this 3 kilonewton, that also gives you the moment. And it will be the same as the total moment that we calculated here. So this total moment that we calculated here will be equal to if you calculate it directly like this. But in this case, you need to know how to find this distance by using the information given to us here. Okay, by using the information given to us. So this is another way of considering the moment. Directly, don't go to the component, but directly use this total of 3 kilonewton, but then perpendicular distance is different now. Perpendicular distance here is different now. We need to find this, okay, or this, same. And how to find this? So you need to find this plus this. This one we know is, if this is 3, so divided by 2, so this one is 3 over 2. Next, you need to find this. You need to find this. How to find this? If this is 30, then this should be 30 as well. Then this one is make use of this height here. This is 6. This one sine 30. So 6 sine 30 give you this. 6 multiplied with sine 30. So this 3 kilonewton multiplied with this perpendicular distance, which is 302 meter plus 6 sine 30, gives you the moment caused by this UDL acting on inclined member, and it will be the same as this value also, where we separate them into component X and component Y and find the moment caused by component X and find the moment caused by component Y. They will be the same. Okay. So that is how we consider problems where you have inclined member. So let me pause here. Stop the recording.